1 plus omega by omega c to power 2n. Okay, when n is the order of the filter, okay, here n is the order of the filter. Already I say order of the filter, and what you observe, and I explain also, when order is increasing, when order is increasing, what is happening? The practical filter is approaching to ideal filter. Yes or not? Means the position of this omega as a stop end, that is shifting left hand side. Yes or not? It is shifting left hand side. We can say that when the order of the filter is increasing, this practical low pass filter is approaching to ideal low pass filter. Yes or not? Just remember yesterday's class. Okay, that is one point. So when order is increasing, it is benefit to us, but problem is we cannot go for a high order design because it requires more manpower and money. Okay, that's why we cannot go for a high order filter design. Clear? Now, this is the first thing. When order is increasing, then ideal filter is approaching to practical filter. And what is the second? Also, you can say that when order is increasing, error, that is 1 minus h of j omega magnitude, or simple h of j omega also can write. Okay, simple h of j omega, no problem. Whole magnitude, it is decreasing. Okay, this is the second point. The error is decreasing. That is also advantage, and also we proved that for Butterworth filter, d I h of j omega by d omega I for omega equals to 0 equals to 0 for I equals to 1 to 2n minus 1. Yes or not? That's why it is its differentiation equals to 0 for more value of or more means more number of differentiation, not first differentiation. Okay, here in case of Butterworth filter, the differentiation of its magnitude gives 0 value for more number of differentiation. Hence, it has maximally flat. It has maximally flat. If a function gives 0 value for single differentiation, it has only one from the flat values, and either maxima or minima. But here in this case, it gives 0 value for so many or number of differentiation. Okay, that's why it has a maximally flat. And last point what we discussed yesterday, that is the asymptotic slope. Asymptotic slope. This asymptotic slope equals to minus 20n dp per ticket. That is you all people know what if omega is increased by factor of 10. If omega increased by factor of 10, then the characteristic will goes down by 20n dp. Yes or not? Or by 20 and simple. This is asymptotic slope. Up to this point, all people clear? Yes or not?
Sir, third point once can you explain, sir? Third point.
Third point again. See, what is h of a j omega? H of j omega is equals to 1 by square root of 1 plus omega c to power 2n. Okay, then I can write like this. So 1 plus omega c to power 2n whole power minus 1 by 2. Then expand this. How will I expand? The formula also already given. 1 plus x to power n equals to 1 plus nx plus n multiply n minus 1 by 2 factorial x square n minus 1 n minus 2 by 3 factorial x cube like this. Here in this case, n equals to minus half and x equals to omega c to power 2n. Then I can write h of j omega magnitude equals to, just use this formula, 1 minus 1 by 2 omega by omega c to power 2n plus some coefficient will get x cube. X cube means a higher power of this is that is plus. I can write higher power of omega c to power 2n. Yes or not? If you want to expand, what will get plus some coefficient, that is 3 by 8. Okay, it is omega by omega c to power what? 4n will get.
Yes,
X
sir.
square is 4n. Then what will
Yes.
get? Again some coefficient. It's omega by omega c to power 6n. Yes or not? Then 8n, like this will get. Okay, now do the differentiation. If we do the differentiation, then what will get? The first is 0. Okay, and if you see second case, it is minus 1 by 2 multiply 2n multiply omega by omega c to power 2n minus 1 multiply 1 by omega c plus same we will do for this. Yes or not? If you want to do also, getting or not, means how will
Yes,
get
sir.
some constant, like some constant c0 or c1 multiply next is what? It is 4n multiply omega by omega c to power 4n minus 1 multiply 1 by omega c, like this will get. Now t h of j omega by t omega for omega equals to 0. What will get? Obviously, all are containing the omega term. This is 0. Yes or not?
Yes, sir.
Similarly, if you go for t square h of a j omega by d omega square for omega equals to 0, again you will get 0.
0.
Okay, because say it is power 2n minus 1, the like this will get 0 up
Yes,
to
sir.
you will go for like this ti h of j omega by d omega I for omega equals 0 when I equals to is 1 to up to 2n minus 1. Okay,
Yes,
yes or
sir.
not? The
Yes,
2n,
sir.
then 2n minus 1, then 2n minus 2, it will go like this. And when it is d of 2n minus 1, then we will get some constant. Okay, sorry, when d of 2n, we will get constant. Get it clear or still doubt?
Understood, sir.
Understood? No? Means
Yes, sir.
say when only single differentiation is 0, then it is a flat point. Flat point means either maxima or
No.
minima. Okay, like this, the flat point. See, either it is maxima or it is a minimum. But if you see here, see, so many differentiation you are getting 0. Yes or not? It's not single differentiation. It is more than one differentiation you are getting 0. That is the reason Butterworth filter has a maximally far. Okay. Now clear?
Yes, sir.
Okay. Now all of it clear? Okay. So this is another. The third one is the asymptotic slope. The asymptotic slope is minus 21 dB per decade. Means already I said yesterday itself the asymptotic slope is, what is the asymptotic slope? It is minus 20 n log of omega by omega c. So if omega is increased by factor of 10, means multiple of what? 10 multiple of omega c, then this is the complete characteristic. It will goes down by 20 n factor. Yes or not? That's why the asymptotic slope is 20 minus 21 dB per decade. Because this minus value, it will goes down. Now clear all of you? Okay. Now today we will try to derive the transfer function of the Butterworth filter. Okay, that is very important. Now see how I am doing the derivation part. H of j omega square equals to 1 by 1 plus omega by omega c to power 2n. Okay, now I can write like this. You all people know that S equals to j omega. So I can write like this. This is your h of s multiply h of minus s. Yes or not? Because h of j omega magnitude square means what? It is h of j omega multiply h of conjugate j omega. Conjugate means this j become minus j. Yes or not? That is h of j omega multiply h of minus j omega. So h of j omega means s, minus j omega means h of minus s. Yes or not? So I can write like this. Or say the concept is we can represent h of j omega magnitude square. I will write the concept here. We can represent h of j omega magnitude square equals to h of s multiply h of minus s if h a of s is an analytic function. Analytic function means it is differentiable for all point of s except the singular point. Okay, means it is differentiable for all point of s except the singular point. Okay, then what is singular point? Say if a function is what s plus a, then s equals to minus a is the singular point. Okay, means the point or the value of s at which the function is infinite. Okay, now let h of s is an analytic function. If h of s is an analytic function, then I can represent h of j omega magnitude square equals to hs multiply h minus s, that is equals to 1 by 1 plus. So now what is omega? Omega means s by j. It is s by j omega c to power this 2n. Okay, or I can write like this: h of s h of minus s equals to, what is this? You can write 1 I 1 plus s square minus omega c square to power n. Okay, because j square equals to minus 1. Okay, now see how many poles are there. Obviously, it's the order of this 2n, so that is 2n poles. So out of this 2n poles, n poles belonging to h of s and n poles belonging to h of minus s. Okay, yeah, I can say there are 2n number of poles, and out of 2n number of poles, n pole belongs to HAS as an atom, and just n pole belongs to H of minus S. Okay, now what is our interest? Our interest is I want all left hand side poles, yes or not? Because all the left hand side poles means the function is just, or the system is stable, yes or not? So we want, what is our requirement? We want n left hand side poles. Okay, for our transfer function, because you all people know that when all the poles lies left hand side of S plane, then the system is stable. And obviously, we want to design a stable low pass filter. Okay, we want an left hand side poles because we want to, what is the reason? Because we want to design a stable low pass filter. There is no doubt. Okay, we want to design a stable low pass filter. Later, all the n left hand side poles belongs to h of s. Okay, and right hand side poles belongs to h a of minus s. Obviously, we are not interested on the h of minus s because when poles lie right hand side of s plane, it is unstable system. It is a unstable system, and when poles lie left hand side, just 1 minute, all of you. Hello, hello. Uh, Madam, actually, I'm in class, madam. After class, I will talk, madam. I'm in college only, in lab. Pen drive. Yes, yes, that pen drive, madam, they will take today. They will, madam. They will are taken. Yes, yes, sir. I think he is in our room, madam. Just once check it. I came to lab for class. Okay, he taken that pen drive to install MATLAB. Okay, madam. Okay. Okay. All of you clear or not what I'm explaining? Yes or not? Hello,
Yes,
student.
sir. Clear, sir.
Okay, it's very simple. So obviously, I want all left hand side poles because we want to design a stable system. Okay. So simple. So what we got, h of s multiply h of minus s equals to 1 by 1 plus s square by minus omega c square to power n. Obviously, there are 2n number of poles. Here n number of poles. N number of poles. This n number of poles belong to h of s. That's n number of left hand side pole, and n number of right hand side pole belongs to h of minus s. Okay, clear? Now see, if you see h of s, h of minus s equals to 1 by 1 plus it is s square by minus omega c square to power n. Okay, now how to find the pole? Yes, if you want to find the poles means what to do? Simple, put denominator equals to 0. Now put it, if you put denominator equals to 0, then 1 plus s square by minus omega c square to power n equals to 0. That is minus of x square by omega c square power n equals to minus 1. Minus 1 means I can write like this. It was j 2k minus 1 pi, because you all people know that it was j pi, 3 pi, 5 pi, 7 pi. Yes or not? These all values are minus 1. That's why it's odd multiple of pi. It was j 2k minus 1 pi, where k is 1 to n, because it is s square. Yes or not? Now you can write like this: minus s square by omega c square equals to, take this n right hand side, it is e to power j 2k minus 1 pi by n. Okay, because it's whole to power 1 by n, that is pi by n, or it is s square equals to minus omega c square e to power j 2k minus 1 pi by n. Then what is the s? Or you can write s equals to plus or minus z omega c e to power j 2k minus 1, it is pi divided by 2n. Okay, clear? Where k equals to 1 to n. Now see, we are getting here plus or minus. Yes or not? So plus, when you take plus, then how many poles? N number of poles. When you take minus, we are getting n number of poles. Okay. Now here plus belongs to left hand side poles, and minus belongs to, I'll write here plus, all the plus means this symbol plus belongs to left hand side pole, and this minus this belongs to right hand side pole. Okay, clear? If you take plus means you will get n number of pole. Okay, how many poles? N number of poles. Similarly, when you take minus also, it is n number of poles, because k is starting from 1 to n. Okay, now you all people know that we are interested on the left hand side pole. We are not interested on the right hand side pole because it is unstable system. So I can take what is our poles, or we can say roots. Okay, it's roots or poles. We can say, that is, I can just write like this sk instead of s. We are interested on the plus type, j omega c e to power j 2k minus 1 pi by 2n, where k is 1 to n. These are the poles. These are the poles. Yes or not? Or You can say this SK, this is what? Poles of H of S. Okay. And if you want to write also, you can write letter Sk dash equals to minus J omega C e to the power J 2k minus 1 pi by 2n k equals to 1 to n. This is your poles of H of minus S. Okay, but we are not interested on this part because this is a non-stable system. Okay, because poles lie right hand side of the S plane. We are interested on this. That is our stable system or stable low pass filter. Okay, now what is the interesting thing you got here? See, now our poles of Butterworth low pass filter is Sk equals to J omega C e to the power J 2k minus 1 pi by 2n. Now if you take magnitude, what you will get? It was J omega C e to the power J 2k minus 1 pi by 2n. If you take a magnitude, then this is J omega C magnitude J 2k minus 1 pi by 2n magnitude, and this is omega C. Yes or not? Because you all people know that it was J theta magnitude equals to 1. So what you got? This Sk is magnitude equals to omega C. What type of equation this is? Can someone? Huh? Yes, sir. What type of equation this is? Mod Z equals to R. This represent what? Whatever equation, circle, ellipse, parabola, whatever equation this is. Yes, sir. Section C and D, what type of equation this is? Mod Z equals to R, what type of equation this is? It's very same. Huh? Z transform over mod Z equals to R, what type of equation this is? X square plus Y square equals to R square, what type of equation this is?
Circle, sir.
Circle. Okay, so it's very bad. Okay. When you people are unable to answer this type of thing, also I'm feeling very pity about you people. Okay. This is circle. So what to understand? Means my point is here, say your poles, when you plot all the poles of Butterworth filter, what you will get? You will get a circle. Yes or not? Because since you got this Sk magnitude equals to omega C, obviously if you plot all the poles of Butterworth filter, you will get a circle of a center at origin. Center at origin. Yes or not? Okay. There is a circle equation. X minus h whole square plus y minus k whole square equals to r square. Then it is a center is at hk and radius equals to r. So here the center at origin and what is the radius? Yes, sir.
Omega C.
Very good. The radius is omega c. Okay. This omega c is a radius. Means if you plot all the poles of a Butterworth filter, you will get a circle. Okay. You will get a circle. Okay. or all the poles of the Butterworth filter lies on the surface of a circle. Okay, that is very, very important. You can say all the poles of Butterworth filter lies on the surface of a circle. Okay, clear? Or you can say that if you plot all the poles of a Butterworth filter, you will get a circle like this. The poles are lying on the surface of the circle. Say, like this poles. If you plot n number of poles, this is a MATLAB equation. If you do a MATLAB program, if you plot all the poles by using this equation, then you will get a circle. So better you can try this in a MATLAB, and so that you can verify. Okay. So what you got here, our SK equals to J omega C e to power J 2k minus 1 pi by 2n. That is J omega C. It is your cos of 2k minus 1 pi by 2n. Okay. Plus J sine of 2k minus 1 pi by 2n. Where k is 1 to n. Okay. That is SK. If you multiply this J omega C or simple SK by omega C, if you multiply this J inside, then what will you get? Minus sine 2k minus 1 pi by 2n plus J cos of 2k minus 1 pi by 2n. Okay. Where k is 1 to n. So this is the denominator part, or poles we can say. Okay. Or you can say it is a pole. Now just we will go for the transfer function. Okay. Now here k is 1 to n. What is n? N is order of the filter. Now I want to write the transfer function. I will start from lower order. Let n equals to 1, the lower order. Okay. Then let n equals to 1. Then what is the k value of k? It is 1 to n. That is 1. Then what are the poles? Let omega c equals to 1. First, we will find the pole by using omega c equals to 1. Then you can replace s by s divided by omega c. Simple trick. Let omega c equals to 1. Okay. Then you all people know this equation represents the poles. Then what is the pole? S1. Okay. S1. Here I am taking omega c equals to 1. Better you can replace s by s divided by omega c. Then simple put k equals to 1. What will get? And n equals to 1 in the equation A. What will get? Minus yes, sine of how much? Put k equals to 1 and n equals to 1 in the equation A. How much will you get? Yes. Put k equals to 1 and n equals to 1. What will you get? What will you get?
Pi by 2, sir.
Very good. Minus sine pi by 2 c. Student, just focus on the whiteboard. These derivations are very, very important because you will get question from the derivation. Each and every point is very, very important. Okay. Especially section C people, because this time I decided I will talk with higher authority. I will give question to all section C and D. Section C people see the derivation part properly, and also D. it's very simple. This k equals to 1, then 2 multiply 1 minus 1 is 1. Pi divided by 2 multiply capital N equals to 1, it is 1, so it is pi by 2. So minus sin pi by 2 plus j cos of pi by 2, then it is a minus 1. Okay, then what is transfer function? Transfer function h of s equals to 1 divided by, when pole is minus 1, how you are writing? It's n plus 1, yes or not? Because the pole is a minus 1, so 1 by s plus 1. Now initially I taken omega c equals to 1. Now what is the transfer function? It's 1 by s by omega c, because I taken omega c initially 1. Now replace s by omega c plus 1, then it is omega c by s plus omega c. Okay, now this is for n equals to 1. Similarly, you can go for n equals to 2 and find it. If you do n equals to 2, then what is the value of k? K equals to 1 and 2, because k is from 1 to n, so n equals to 2, so k is 1 2. Okay, then I can write what is s1. Same, first take omega c equals 1, later we will replace. What is s1? It's minus sine of pi by 4 plus j cos of pi by 4, that is minus 1 by root 2 plus j by root 2. Similarly, put k equals to 2, what will get? Minus sine 3 pi by 4 plus j cos of 3 pi by 4, that is equals to minus 1 by root 2 minus j by root 2. Okay, then what is the transfer function? We can write the transfer function h of s equals to 1 divided by, simple, it is a 1 s plus 1 by root 2 whole square plus it's a, okay, I will write that side. What you got for n equals to 2, k equals to 1 2, then what you got? sk you got here minus 1 by root 2 plus or minus j by root 2. Yes or not? See, it's minus 1 by root 2 plus j by root 2 minus 1 by root 2 minus j by root 2. Now, if you see, these are the poles, then what is transfer function? Equals to h of s equals to 1 divided by s plus 1 by root 2 whole square, because it's the complex conjugate, plus 1 by root 2 whole square. Then what will get? 1 by s square plus root 2s, because 2ab plus b square means 1 by 2 plus this is 1 by 2. So what we got here? h of s equals to 1 divided by s square plus root 2s plus 1. Now initially I taken this omega c equals to 1. Now what to do? Simple replace s by s divided by omega c. Then what is our transfer function? It is 1 divided by s by omega c square plus root 2 s by omega c plus 1. Then what will get here? Get omega c square divided by s square root 2 omega c plus omega c square. Okay, clear all of you? Yes or not?
Yes, sir.
Now same way you can do for n equals to 3. When you take n equals to 3, what are the value of k? 1, 2, 3. Okay. Then same you find what is S1 when k equals to 1 and equals 3, then it is the same. Initially I'm taking omega c equals to 1, it's minus sine 5 by 6. Okay. Plus j cos of 5 by 6. Then it is minus 1 by 2 plus j root 3 by 2. Okay, simple put in this equation. Always use equation A. Okay, how will get to k equals to 1 means 1, then 3, then 5, then 7 will get like this. Okay, then what is next to say? It's very easy to write minus sign this pi na, then 3 pi by 6. Then 5 pi will come. Plus j cos of 3 pi by 6. Sorry, cos of 3 pi by 6. Then this 5 by 2. The answer is minus 1 because cos pi by 2 is 0. Then what is S3? Minus sign. Now 3 means 5. 5 pi by 6 plus j cos of 5 pi by 6. Then the value is minus 1 by 2 minus j root 3 by 2. Okay. Now what is transfer function? Same. These are the poles. See, this is complex conjugate with each other. This is one real pole. Then we can write the transfer function equals to h of s equals to, first you take this real pole, that is s plus 1. Then what will get? Take this complex conjugate pole. What will get? S plus 1 by 2 whole square plus root 3 by 2 whole square. So what will get here? Then if you do, then we'll get 1 divided by s plus 1. And if you do this simplification, we'll get here s square plus s plus 1. Now what to do? Replace s by s divided by omega c. Then finally we get h of s equals to, if you replace s by s omega c plus 1, this is s square by omega c square plus s by omega c plus 1. Then finally we will get here h of s equals to omega c cube divided by s plus omega c multiple of s square omega cs plus omega c square. Okay, now I explain here up to order 3. What you observe say, when n is odd, we are getting one pole at omega c, rest 2 is complex conjugated. Yes or not? When n is even, we are getting only complex conjugate pole. Yes or not? This is the observation. See, when n is even, we are getting only complex conjugate pole. But when n is odd, we are getting complex conjugate pole. This is the complex conjugate pole. This is a one pole at omega c. See here, where n is odd, what are we getting? We are getting one pole at omega c. Clear? This is the observation. Now I want to generalize this. How we can generalize this? Say, now what are we getting? What is the observation people did? The observation is if n is even, we are getting only complex conjugate pairs. Complex conjugate pairs and then n is odd, we are getting complex conjugate pair and also one pole at omega c. Yes, sir. Agree, all of you? Yes or not? Yes. C and D. Just see here. If you see when n is odd, you are getting only you are getting complex conjugate pair plus one pole at omega c. When n is even, we are getting only complex conjugate pair, no pole at omega c. Okay. So this is two observation we got from our derivation. Now I will use this observation to write my transfer function. Now let the pole, what is the pole we got? It is sk equals to minus sine of 2k minus 1 pi by 2n. Okay, that is sk by omega c plus j cos of 2k minus 1 pi by 2n. Now complex conjugate pair means what I can write? Can I write like this plus or minus? Yes or not? Okay. Yes or not? All of you? How this complex conjugate pair? How this complex conjugate pair? Can I write this plus or minus? Yes or not? See here. We are getting 1 plus 1 minus. Okay. Similarly, here see, we are getting plus or minus. Here also we are getting, here only 1 because order equals to 1. Okay. So can I write like this plus or minus? Yes or no? Section C and D. If people are getting or not? Huh? I'm writing everything so that the people will understand that. Yes? Yes or not, all of you? Akhil, what's the problem? Getting or not? Yes?
Sir.
Amrita? Yes, Amrita?
Yes, sir.
Okay. Sravya is there? Okay. Now, how we can write denominator? This is complex conjugate poles. Let omega c equals to 1. Let. Then how can I write denominator? I can write denominator like this. Like what we did before, say. It's very simple. Okay. Same way I will write. I can do like this denominator. X plus sine of k minus 1 pi by 2n whole square plus cos square 2k minus 1 pi by 2n. Simple because it's complex conjugate pair. Then what will get? We'll get s square plus 2 sine of 2k minus 1 pi by 2n s plus 1. Because here we'll get sine square, here it's cos square. Sine square theta plus cos square theta equals to 1. Okay, so this is your denominator. Then what is our transfer function? If you want to write our transfer function, how you can write it? Let n equals to even. For n equals to even, if you want to write the transfer function, how you can write it? This h of s equals to 1 by. Okay, now this complex conjugate pair, yes or not? Means 2 pole equals to 1 complex conjugate pair. Okay, then n number of poles. Then how many complex conjugate pair? N by 2, yes or not? n by 2. So how you can write the denominator? This transfer function. It's a multiplication of k 1 to n by 2. Simple this is s square plus okay. Let pk equals to 2 sine 2k minus 1 pi by 2n. Let pk equals to 2k 2 sine 2k minus 1 pi by 2n, where k equals to k will define, no problem here. Now we can write k equals to 1 to n by 2 s square. Now what? This is bk, this is s plus omega, sorry, plus 1. Okay, for n is even. Okay, clear? Now same way I can write for n equals to odd. What is the difference? If n equals to odd, can someone, what is the difference? We are getting complex conjugate pair and also one pole at omega c. Yes or not? Now, for this case, let omega c equals to 1 I taken. So, if you see here, just I written here only. When n is odd, we are having complex conjugate pair plus one pole at omega c. So, how we can write? I can write like this: 1 by s plus omega c, because s plus 1, sorry, because omega c equals to 1 I taken. 1 pole at omega c. So omega c equals to 1 I taken here. So s plus 1 multiply k equals to 1 2. Now see, out of n number of pole, 1 at 1 at 1. Once 1 pole at 1. Then how many poles left? There are n number of pole. Out of n number of pole, we are having 1 pole at minus 1. Okay, clear? Then how many poles left?
Complex conjugate pairs.
How many poles left? Out of n number of pole, n number of pole is total 1 pole at minus 1. So n minus 1, what is the value? It's very sad. People are school people or engineering people stout. Huh? Out of n number of pole, 1 pole at minus 1, then how many poles left?
n minus 1.
N minus
n
1
minus 1.
poles.
Now 2 pole equals to 1 complex conjugate pole, pairs pair. Then n minus 1 poles means how many complex conjugate pair? Huh?
n minus 1
N minus 1
by 2.
by 2, which is s square plus bks
Yes. Plus 1.
plus 1. Okay, clear? See, both are same. Only the difference is in case of even, there is no pole at minus 1, there is no pole at omega c. But in case of it is odd, we are getting one pole at minus omega c. Okay, because one pole at is minus omega c, yes or not? Because we are getting s plus omega c every time. See, we are getting s plus omega c. So one pole at minus omega c. Okay, now what to do? This is let equation 1. This is equation 2. Equation 1 represent transfer function of a Butterworth filter. Then n is even. And equation 2 represents a transfer function of Butterworth filter where n is odd. But in both cases, what it did? I taken omega c equals to 1. But omega c not equals to 1. Yes or not? So what to do? Again, replace s by, say, s divided by omega c. So finally, what we get? Say, n equals to even, we got h of s equals to 1 divided by k equals to 1 to n by 2 s square plus bks plus 1. Okay. That bk equals to 2 sine of 2k minus 1 pi by 2n. And when n is odd, we are getting h of s equals to 1 divided by s plus 1 multiply k, this is the multiplication, okay, k equals to 1 to n minus 1 by 2 s square plus bks plus 1. In both cases, I taken omega c equals to 1, but actually omega c not equals to 1. So what to do? Replace s by s divided by omega c. So what is the transfer function? So when n equals to even, now replace s by s by omega c. So n equals to even, what we get? H of s equals to, it is omega c to power n. Simple, replace s by s divided by omega c, and it is omega c to power n multiplication of k equals to 1 to n by 2 s square plus bk omega cs plus omega c square. Similarly, when n equals to odd, h of s equals to omega c to power n divided by, simple, replace this s by s divided by omega c. We get omega c to power n s plus omega c multiplication of k or 1 to n minus 1 by 2 s square bk omega cs plus omega c square. Okay, so this is for n equals to even, this for n equals to odd. This to represent a transfer function of a Butterworth filter. We have to remember this equation. Okay, this is a transfer function of a Butterworth filter, and you all people remember this equation. Clear, all of you? Okay, so this is complete transfer function. So next class we will discuss how to find this order of the filter. Okay, how to find this order of the filter, because to write this transfer function you want order of the filter. Okay, here I will write here n is order and bk is 2 sine of 2k minus 1 pi by 2n. Okay, so this is the thing. The transfer function of Butterworth filter, n is the order of the filter, and this bk coefficient bk is 2 sine 2k minus 1 pi by 2n. Okay, this is the complete derivation. I will upload this video in YouTube after this class, so that if people what to do, if people wants to go through this video, you have to write completely